Hello to you. Welcome to my channel. Today's math tutorial is a trigonometric identity problem. If tan A plus B is 1 and tan A minus B is 1 over 7, find the values of tan A and tan B. Do you remember the trigonometric identities for tan A plus B and tan A minus B? Now I know that you're figuring that out, but here you are. For tan A plus B, it is tan A plus tan B over 1 minus tan A tan B while for tan A minus B, it is tan A minus tan B over 1 plus tan A tan B These values are given to us as 1 and 1 over 7 respectively. So from the first, which is tan A plus B, we are having tan A plus tan B over 1 minus tan A tan B, and that is equal to 1. Now we are going to let tan A be M, and we designate tan B N. This simply means that the tangent of the sum of the multiple angles A plus B becomes M plus N over 1 minus Mn, and this is equal to 1. We will continue to simplify this first by taking the cross product, where the sum of M and N will be equal to 1 minus Mn. Then we're going to add Mn to both sides and subtract N from both sides, such that we have M plus Mn and 1 minus N on the right. So M is factored from the left, where we have M times 1 plus N in parentheses, and that's equal to 1 minus N. And we divide both sides by 1 plus N, which when it is done, M is equal to 1 minus N over 1 plus N, which we call equation 1. If you are yet to subscribe to my channel, please do subscribe now. Click on the notification bell so that you get updated when new math tutorials are made. Equally, tan A minus B, which is tan A minus B, which is tan A minus tan B rather, over 1 minus 1 plus tan A tan B, from the problem is 1 over 7. Don't forget that tan A has been represented with M, so that's N minus N, N for tan B over 1 plus Mn. And this is equal to 1 over 7. Then taking the cross product, we have 7m minus 7n to be equal to 1 plus Mn. We subtract Mn from both sides and add 7n to both sides to give 7m minus Mn, and that's equal to 1 plus 7n. Factoring m gives 7 minus n in the parentheses on the left, and that's equal to 1 plus 7n. Then we divide by 7 minus n. M is 1 plus 7n over 7 minus n. This is our second equation. Don't forget, the first equation is M is equal to 1 minus n over 1 plus n. So we're going to equate the two equations because they are both the values of m. And that means 1 minus n over 1 plus n is equal to 1 plus 7n over 7 minus n. We take the cross product, and that will be 1 plus n times 1 plus 7n. On the right hand side, it is 1 minus n times 7 minus n. We remove the parentheses by distributing the first over the second on both sides, such that on the left hand side we have 1 plus 7n plus n plus 7n squared. And on the right, it is 7 minus n minus 7n plus n squared. All the terms are taken to the left, and we group them based on the degree, such that 7n squared minus n squared plus 7n plus n plus n, then plus another 7n, when the ones on the left are moved to the right. Then plus 1 minus 7, everything is equal to 0. So we have 6n squared plus 16n minus 6 to be equal to 0. 2 is a factor of all the terms, so we divide through by 2. That gives us 3n squared plus 8n minus 3 to be equal to 0, a quadratic equation. Now, looking at the leading coefficient and the last term, the product gives negative 9. And the factors of negative 9 that add up to positive 8, these are negative 1 and positive 9. So we use this to split the middle term. And the quadratic equation becomes 3n squared minus n plus 9n minus 3 to be equal to 0. Double grouping to be able to factor the common terms. We have n times 3n minus 1 from the first group, y plus 3 times 3n minus 1 also from the second group, and that's equal to 0. So 3n minus 1 is factored out, and we have times n plus 3 to be equal to 0. So by the zero product property, 3n minus 1 is 0, or n plus 3 is equal to 0, such that 3n is equal to 1, or n is equal to negative 3. So the values of n are 1 over 3 or 3, or negative 3 rather. Now that we have the values of n, we plug them into any of the equations that we have above. We're going to be specifically using equation 1 to get the corresponding values of m. Recall that equation 1 is m is equal to 1 minus n over 1 plus n. So when n is 1 over 3, m is going to be 1 minus 1 over 3 divided by 1 plus 1 over 3. And this is 2 over 3 in the numerator divided by 4 over 3 in the denominator. This is 2 over 3 times 3 over 4. One over 2 is the value of n when n is 1 over 3. Also, when n is negative 3, n is going to be 1 minus negative 3 over 1 plus negative 3. This is 4 over negative 2, and that is negative 2. Recall that M is tanA and N is tanB. This simply means that the values of tanA are 1 over 2, which are the values of M, and negative 2, while the values of tanB, which is N, are 1 over 3 and negative 3. Here is the solution of the trigonometric identity problem, and I believe you enjoyed today's math tutorial. Please let me know your thoughts about this solution in the comment section. Don't forget to like, share this video, and if you're here to subscribe to my channel, please do so right away and click on the notification bell so that you get updated from time to time about my activities on this channel. Thank you for watching this video, and bye.